You can also go through the recorded lectures whenever you want.
Didi?
Yes. Are you saying something? Devana? I'm sorry if I'm pronouncing your name incorrect. So let's begin with today's lecture. Welcome everyone to the NPTEL course on the novel technologies for food processing and shelf life extension. So the course instructor is Professor H.N. Mishra, Professor in the Agriculture and Food Engineering Department, IIT Kharagpur. I am Shikha Sharma. I am a research scholar in the Department of Chemical Engineering, IIT Guwahati. And I'll be the TA of this course for the January 2025 semester. So this is a basically live interaction session for the week 1, which is on the topic Introduction to Food Processing, Preservation and Quality, Basic Principles and Methods, Water Activity versus water activity means like how it affects the food stability, structure, function, relationship. So uh, I hope you have all gone through the 5 lecture videos which are related to the week 1 topic. So in this live interaction session, we will be solving or we will be practicing some of the problems, and we will understand the the concept behind of the problems. And if you have any doubt regarding the lecture videos, uh, or you have any doubt regarding the live session, please feel free to ask. I'll try to solve your queries at the moment or at the beginning of the next week, if not in the at the moment. So let's begin with the class. Also, like if any interruption in the internet will occur, please you can join with the same link. Okay. So the topic that we will be discussing in the today's class are food constituents and functions, quality and safety aspects of food, factors affecting quality during the processing and storage, role of water in food and its shelf life, gelatinization and retrogradation of starch. So we will be trying to solve some of the problems regarding it. So let's move to our first question. Align the reactions listed in the column 1 with the corresponding changes in food quality indicated in column 2. So in column 1, all the we have all the reactions like the bruising of fruits, hydrolysis of the polysaccharides, lipid oxidation, heating of muscle tissues. And in the column 2, we have the changes in the food quality, like the development of the off flavors, enzyme inactivation, protein sugar reaction, and the enzyme release. So, anyone of you would like to solve the problem and would like to give any answer? Anyone? Like why the bruising of the what when there is a bruising of the fruit? So what it creates? So let's see the answer. So the option D is correct. Like when there is a bruising in the fruit, so there is a result in the release of the enzymes. Like there are some enzymes like polyphenol oxidase. So these, like when there is a bruising during the transportation, handling, or the storage, so these kind of degradative enzymes they release. Uh, so bruising is related to the enzyme release. Then hydrolysis of polysaccharides or the breakdown of the polysaccharides. It basically occurs when there is a reaction with the protein, which is the sugar protein reaction, which is also known as the Maillard reaction, in which the sugar and the amino acid they react and they uh, degrade the polysaccharides and produces both the desirable and undesirable changes. The third one is the lipid oxidation. So lipid oxidation is related to the like it is related to the development of off flavors, because when there is the lipid, it oxidizes in presence of the light and the oxygen, so which causes the rancidity. So due to the rancidity there is the development of the off flavors. So option 3, which is the lipid oxidation, is related to development of off flavors. The fourth is heating of the muscle tissues. So it is related to the when we heat the muscle tissues due to the high temperature, several enzymes they get deactivated, which are the undesirable enzymes, and the shelf life get extend. So it is related to fourth is related to enzyme inactivation. So is it clear? Can we move to the next slide? Next question.
Yes, ma'am.
Yes, ma'am.
Okay, thank you. So next question is, which among the given options represent an undesirable change that take place during the processing of food products? So when we process the food products, it may undergo some undesirable changes and it may undergo some desirable changes. So out of these, which is the undesirable change that takes place? Option A is chemical modification of the polymers, which can be through the hydrogen bonding, hydrophobic interactions, and the cross-linking. Option B is gelatinization and chemical alteration of the starch, conversion of the glucose to fructose. Option D is enzyme regulation, which can be through the thermal denaturation. Option D is development of cooked flavors in the ultra high temperature UHT processed milk. So, which option can be correct? Anyone would like to answer? So, first let's understand what is ultra high temperature. Mostly, like in the milk, we process it to increase the shelf life using ultra high temperature processing, which involves the heating for around like 1 to 8 seconds at 135 to 154 degrees Celsius. So, for a very high temperature and for a very short time, we do ultra high temperature processing. The answer is the because when we do ultra high processing of the milk products, it gets the cooked flavor. It develops the cooked flavor, which is not desirable. While the chemical modification in the polymers, it is a desirable um, reaction. Like it's a desirable change because when we do the chemical modification of the polymers, we can get the desired polymer chain, which can be applied for the different kind of applications. And the gelatinization of the starch, it is also like desirable. Also, the when the glucose, which is a high um, like contributor to the blood glucose, so when it converts to the fructose, it is also very a desirable change. And the enzyme regulation, like when we heat, do the thermal degradation, and the enzyme get deactivates and the enzyme regulates, it is also a desirable. So these three cannot be undesirable. These are the desirable one, and this is the undesirable one, the last one, which is the development of the cooked flavor in the milk. So there are many desirable changes which occur in the food while the processing, like the I think someone is unmute or there is some disturbance. I request to mute, please. Okay, thank you so much. So the desirable changes, which includes the enhancement or maintenance of sensory qualities like the color, flavor, and the texture. So these are the desirable changes. It occurs when the food is being processed. Like there are some chemical reactions like the lipid oxidation, Maillard reaction, Straker degradation, in which the amino acids it is being converted into the aldehydes and the ketones, or the caramelization of the sugar at the high temperature, which develops the brown color and the different kind of caramelized flavor, which is also desirable. And there are some enzyme driven reactions which are also very desirable. Uh, Also like the chemical transformation of the polymers, which is through the hydrogen bonding, and the hydrophobic interactions and the cross-linking due with the help of the multivalent ions like the Ca+2, it gets bond, it forms a bond in the pectin to increase the texture of a food product. So usually when we have the carrots, we treat it with, like, we dip in the calcium water to increase the like the textural properties, because it forms Ca+, Ca2+, it forms the like cross linking with the pectin polymeric chains, and it increases the overall texture of the carrot. So, or any biomass or any plant material which is having like the polymeric linkage. Usually pectin is there in all kind of the like all kind of the food materials, because it's present in the cell wall, so it increases the texture. So that is also a desirable. And the second point, it says that when we process the food, so functional properties of the food ingredients, it get enhanced, like starch, it get gelatinized, and it's a desirable one. And the transformation of the glucose to fructose. So I told you that we discussed just now that the glucose is a like higher blood sugar contributor. So the we try to convert in the better or the healthier option, which is a fructose. Also, the alkaline treatment of the soya protein. It is or like the soya proteins, they are being treated with the alkalized to increase its solubility and the temperature resistance. So it is required. All these changes are intentionally we do to get better properties. The third is we control the enzyme by the help of the either we increase the temperature or we change the pH or we do the chemical inhibitions or alterations or removal of reactants, and sometimes we do the chelation. So all like we do such kind of the processings which we for like which helps in the enhancement of the uh, quality or the organoleptic quality or the shelf life of food products. But they, by when we are doing these kind of food processing operations, there may develop some undesirable changes, like we can see the uh, there is a change in the organoleptic properties such as the cooked taste in the UHT milk, or the loss of the vitamin C or chlorophyll compounds, and sometimes like the texture in the canned product, they get like it's not very good, it get degrades, and the frozen fish and the seafood, in those the muscles they get toughened. So, and the second is sometimes uh, sometimes because we are doing processing, the functional attributes, they like they get changed, like the protein it denatures at a high temperature and it loses its property of emulsification and forming the forms. And the third is sometimes there is a nutritional value reduction and generation of the harmful compounds. So, like vitamin C, usually when we treat food at a high temperature, the vitamin C is lost. And sometimes like acrylamide or the trans fat, like harmful compounds, they get generated during the processing. So, I hope this much is clear. Any doubt so far? Hello, students. Is
No,
it
ma'am.
clear? Okay, okay.
Yes, ma'am.
Thank you so much. Doubt? So we are moving to the
मैम एक डाउट है.
yes,
हेलो
yes, please.
मैम एक डाउट है असाइनमेंट की टाइमलाइन के रिगार्डिंग. जो हमारे पास ईमेल आई है उस पे असाइनमेंट वीक 1 की लास्ट डेट लिखी है 5 Feb 2025
Hmm,
और जो
hmm.
डे है वो पेरेंट्स डे है. बट 5th Feb को वेडनेसडे नहीं है, तो हमें समझ नहीं आ रहा लास्ट डेट क्या है वीक 1 असाइनमेंट की।
Okay. I should also like ask and I will get to like I'll share with you in the forum discussion forum. Okay, is it fine? Because I
Yes.
have not seen that.
On Wednesday.
Okay, yeah, I understood your point, but I think it's just the misunderstanding of the day. I think the 5th is the final date. But let me reconfirm, and I'll share with you. Okay, is it fine?
मैम 5th को Wednesday ही है.
5th को Wednesday ही है. So last date is 5th. So please try to submit on time. Okay, so we are moving to our next problem, which is about which among these does not belong to the category of natural antimicrobial present in the cow milk. Lactose peroxidase, hydrogen peroxide, hydrogen sulfide, and the thiocyanate. Please, anyone?
Hydrogen sulfide.
Hydrogen sulfide. Okay, so we have one answer. And others would like to try?
Hydrogen peroxide.
So,
Hydrogen peroxide.
yeah, hydrogen sulfide is the right answer. Because like in the bovine milk, which is the cow milk, there are the different antimicrobial agents present like the lactoferrin, lactoperoxidase, and lysozymes. So the lactose peroxidase, this system is having the natural antimicrobial agents, antibacterial agents, which are present, and it has the 5 systems like the lactose peroxidase enzymes, the glucose oxidase enzymes, sodium thiocyanate, sucrose, and glucose. In the bottom, we can see the reaction also. Like what happens in the presence of the lactose peroxidase, this enzyme, it basically catalyzes the reaction of the thiocyanate, which is this thiocyanate ion. It gets oxidized with the help of the hydrogen peroxide, and it forms hypothiocyanate and water. So this hypothiocyanate is basically an antibacterial or antimicrobial agent which helps the milk and to protect from the bacteria. The H2S, which is hydrogen sulfide, like it is never like not involved anywhere in the lactose peroxidase system. So the option C, it is correct, like it is not belonging to the natural antimicrobials present in the cow milk. So let's move to the next question. So in the column 1, we are having the hazards, the food safety hazards. In the column 2, we are having either their respective sources or any relation with that. So we have the first hazard, which is like inherent to food. Second is the hazard which are due to environment. Third is microbial activity, due to microbial activity. Fourth is when we process the food, there are some hazardous substances developed. So these are our options. Please try to hit.
Answer B.
Yes, the option B is correct, because we have the inherent hazards which are basically occurring in the food, and they are basically the toxins, allergens, and the ingredients which we cannot tolerate. So the option first is the allergens, the ingredients which our body cannot able to tolerate. So these are some they can be like we have the in the food packet there are this warning written. There is this warning written that there is a peanut in this. So some people are allergic to peanut. That means that those proteins, the peanut is having those kind of proteins inherent to it, so it causes the allergy to to human beings, to some of the individuals which are not able to digest them. And the second is the hazard which is produced from the environment. So it can be any organic pollutants, heavy metals, radionuclides, and some compounds, some compounds which comes from the environment. So the option second is related to B, radionuclides. Third is hazards, which is arise due to microbiological activity. So these can be any viruses, bacteria, or any biogenic compound amines, or the mycotoxins, which are the toxins generated from the fungi. So this is related to the option C, which is mycotoxins. The hazards which are associated when we process the food is related to the chloropropanols. So basically, when we process any food, so there can be a development of the compounds like acrylamide. We have heard so much about acrylamide, like there is this compound called acrylamide which are present in the food products, and it causes the uh, it was before in the news also sometime before. So it basically what happens like with the acrylamide, when the starchy foods like the fried, baked, or roasted, like when we treat it at the high temperature, so the starchy food they react with the aspergillin. Uh, it like undergoes and it forms the acrylamide, and because of the production of the acrylamide, it it cause hazard to the people who are consuming it. So it can generate while the food is being processed. Second compound is chloropropanols. So they are basically found in vegetable oils, baked goods, and infant formulas. And it basically form the glycerol, when the glycerol it reacts with the chlorine. It reacts with the chlorine. In the acidic condition, it forms chloropropanols. So our option B is correct. So let's move to the next question, which is about like we have
Please
the
once again show that
polysaccharide
reaction.
reaction. Yeah, is it okay? The glycerol it reacts with the chlorine, and when there is a acidic conditions, acidic environment is there, so it forms chloropropanol. So in vegetable oils, when we process it, so it develops or the chloropropanols, which is a hazardous substance. Is it okay? Can we move to the
Okay,
next
ma'am.
question? Okay, thank you. So these are different polysaccharides we have. Four polysaccharides: gelatin, carrageenans, amylase, alginates. So it is in out of these which have the egg box junction cross link. It depends on the structure of these This question basically depends on the structure of the polysaccharides. So which of the polysaccharides is having egg box junction crosslinks? Anyone?
Alginate. D option.
Alginate. So we have one person for the D. Other person would like to try. So, yes, gelatin. So another person is for voting for gelatin. So we have
Yeah,
two
gelatin,
options
ma'am.
now. Okay,
Gelatin, ma'am.
gelatin is getting more votes now.
Gelatin, ma'am.
Option D, ma'am. Alginate.
Okay, one more for alginate. Two people for alginate.
Gelatin, ma'am.
And many, I think 3 to 4 people voting for gelatin. So let's see. So the alginate
Ma'am,
is the
option
correct
D,
answer.
alginate.
Yeah, option D is the correct answer. What happens? The egg box junction, it basically found in the certain charged polysaccharides like alginate. Also in the pectin structure is also the egg box junction. In that there is egg box junction crosslinks. So it founds this kind of structure in the charged polysaccharides like the alginates, where we have the divalent cations. Like here it's the calcium. So calcium is a divalent cation. So we have this kind of structure. Then the alginate, it possesses regularly spaced negatively charged particles which enable divalent cation like the Ca+2 to form the bridges between two parallel polymer molecules. So the alginate is basically a monomer of the 1,4 linked beta D monouronic and alpha L glucuronic acid. So these monomers, like here where M is written, this is the monouronic acid, like both sides, and this is the this one where egg box junction is forming. Glucuronic acids are there. So in the glucuronic acid, we can see we have the we have the negatively charged particles like COO minus, which are separating it, which are giving some kind of space. So in this space, the Ca+2 ion can go, and it basically bridges these parallel polymeric molecules and create a rigid junction like structure. So these junctions, they basically uh, tend to organize into microcrystalline region, and these junctions are uh, very rigid and they cannot dissolve even at the temperature of 100 degrees Celsius. So this kind of structure, when it forms, it is called the egg box junction crosslink, and it is found in alginates mostly, which is alginate is a like extracted from the brown seaweed also, right? Is it clear?
Yes, ma'am.
Okay, so now you understand why alginate is the correct option. So let's move to the next question. Calculate the temperature in degree Celsius at which the rate constant for a first order reaction with an activation energy of this much. Temperature is given as 25 degrees Celsius. So the rate constant is getting doubled here. So, and the gas constant is given where the value is given. So we need to calculate the temperature. So these are the temperature in degree Celsius. Which option like we can correct? Let's solve this problem. So it is given in the question that the rate constant, calculate the temperature at which the rate constant is going to be doubled. So if we are assuming K1 as our first rate constant, so at the temperature 25 degrees Celsius, so K2 is the rate constant at the temperature which we need to calculate, right? So we are assuming is at K2, and it is given in the question that K2, which is the rate constant at the temperature which we need to calculate, is the double of the K1. So K2 equals to 2K1. And we know that as per the Arrhenius equation, K equals to AE to the power minus EA by RT. Here K is the rate constant, A is the Arrhenius constant, E is the exponential to the power of minus EA by RT, which is minus of activation energy divided by rate constant, gas constant into the temperature. And here the temperature should be in Kelvin.
বেরাতে হবে আর লেট করে লাভ নেই 2 ঘন্টা মতো লাগবে ঝাড়গ্রাম
ঠিক আছে তুই
সমলেশ্বরী
কাজ আছে তো
এক্সপ্রেস
ঠিক
টাইম
আছে চলো
I'm
ঠিক আছে
sorry,
সমলেশ্বরী কোথায় যাবে
someone is unmute.
একটা ক্লাস হচ্ছে
Can you please mute?
ফুড সেফটি আমরা 3 ফুড সেফটি করছি তো
ঠিক আছে আমি
হ্যাঁ ঠিক আছে
So yeah, let's take the log on both the sides. So ln K equals to ln A, since it's in multiplication, so it will be plus here, plus ln to the power ln E to the power minus EA by RT. So we now ln A we are shifting to left hand side. So ln K minus ln A equals to ln E minus EA by RT. So it's in minus, so we can take it as the fraction ln K by A equals to, since here is natural log both, and so it can be resolved, it can be solved as minus EA by RT. So since we have the first condition, which is for K1 and temperature T1, which is at 25 degree Celsius. Temperature is 25 degree Celsius. So ln from this equation ln K by A. So ln K1 by A equals to minus EA by, here T is converted into T1. So EA by RT1. We have the EA value given in the question. So we can put this value. R is a gas constant and its value is 8.314. T is 25 degrees Celsius, but we need to convert it into Kelvin. So 25 plus 273, which is 298. So this is our equation 1. So equation 1 is ln K1 by A equals to minus 50,200 divided by 8.314 into 298. Now similarly we will do for condition 2, which is for K2 and temperature T2. So ln K2 by A equals to minus EA by RT2, which is equals to, since EA value is given, so we can put as 50,200 divided by gas constant, which is 8.314 into T2. T2 value is not given to us, so we are keeping it like this. Now we know from the question that K2 equals to 2K1. So in this equation, we can put the value of K2 as 2K1. So it will look like ln 2K1 by A equals to minus EA by RT2, which is equals to minus the same on the right hand side, which is 50,200 divided by 8.314 into T2. So here this can be written as ln 2 plus ln K1 by A, because it is in the multiplication, like we are separating 2 and K1 by A. So it can be written like this, and the right hand side part, which is the same, like the minus EA by RT2. Now from the equation 1, we can put the value of ln K1 by A into the equation 2, which is this equation. So ln 2, it will now, the equation 2 will look like ln 2 plus ln K1 can be written as this value, minus 50,200 divided by gas constant 8.314 into temperature 1, which is 298 Kelvin, equals to, so the in the equation 2, the right hand side is the same, minus 50,200 divided by 8.314 into T2, which is still unknown. So ln 2 is equals to 0.693 minus, when we solve this, we'll get 20.262 equals to 50,200 divided by 8.314 will going to give 6038.008 divided by T2. So from here we can calculate T2 as minus 6038.008 divided by the value which we get from this, which is minus 19.569, and after dividing we can get the 308.55 Kelvin. So it's in Kelvin. Now we need to convert it into degree Celsius, which is minus 273, and the answer is 35.55 degrees Celsius, which is not A, it's in B. So this question clear, the solution part?
Hello?
Yes,
Hello.
ma'am.
Any
Hello?
doubt? Yes.
Ma'am,
Hello.
how is ln2 is equal to 0.693?
It's like in the calculator you can do ln2 equals
It
to,
is the
because
value of lag 2.
it's in ln, which is
Okay.
natural
Okay,
log.
okay.
Natural log. ln2
Okay,
is
okay, okay.
natural log. It's not log. Log,
Okay.
when we write log, log, it's 10. Its base is 10.
Okay.
Its base is E.
Thank you.
Yeah. Actually, it can be doubt for other people, so I'm trying to explain it.
Ma'am, can you show the question, please, where the formula is given? Thank you.
Hello?
Yes. Yes, please share your doubt. So I'm moving
Hello?
to the next. Yes, please share your doubt.
Ma'am, will the recording and PDF be shared after this
Yes.
session?
The PDF will also be going, like the lecture presentation will be shared. Also, the lecture recorded videos will going to be uploaded. No problem in that. You can go through any time.
Okay, thank you, ma'am.
Okay.
Ma'am, what is the protocol of assignment submit?
Can you please repeat?
मैम प्रोटोकॉल क्या है सबमिट असाइनमेंट सबमिट का इसमें एवरी वीक जो बोला गया है?
Yes, every week on the 5th, like this assignment one, you have to submit on 5th, right? So you have to you have to submit each week's. It will be better if you do every week and submit, because every week you're gonna get like at the end you're gonna get assignments for every week, and it will be marked. That will be marked. So please submit it on time.
मैम सबमिट कहाँ करना है? ईमेल पे
There
या फिर
submit button is there, right?
Ma'am,
Can you
so
do?
we just have to choose the option, na? We don't
Yes,
have to
yes,
explain the answer.
yes. But you should know, because you will gonna get examination also for the same, and you should understand the concepts for each and every like question behind, and you can so that you can solve during the examination.
Ma'am, the examination would be subjective or objective?
I'm not sure. Right now I have no information regarding it, so I cannot share right now. I'm sorry.
Okay.
Ma'am,
Okay,
exam
so
will be offline or online?
I think it's offline on the examination centers, but still, like I'm not sure about it also.
And are we going to get the PDFs of the like assignment, like lecture one, lecture two, that are given there? Are we going to get the
For
PDFs for any revision?
assignments or for practice problems?
Ma'am, the recorded lectures that sir gave us and he explained us the theory and all.
Yes.
I'm
So
asking about that PDF for
no,
revision.
it's like it's the video only, and the video are always there. You can go through anytime.
All right, ma'am. And ma'am, where we will get the PDF of this meeting?
Yes.
The video? We will get it
Yes.
on
Yes.
emails or on YouTube?
On Google Drive, I will upload this PDF, the PPTs. I will upload, and the recorded videos will also be there. It will be there on Teams. If not, my YouTube channel, gonna upload it.
Okay.
Ma'am, it is very difficult for us. आप अगर PDF पहले भेज देती तो शायद हम लोग ये क्वेश्चन का आंसर इजीली सॉल्व कर पाते. That's new for
That's
us.
why I'm explaining the solution also, right? That's why I'm explaining the solution also.
Okay.
Yeah.
Ma'am, please mention your YouTube channel also.
Yeah, at the end of
Please,
this
please.
slide, we have, I put the link on the last of this slide. Okay, is
All
it
right.
fine?
All right.
Okay.
Thank you, ma'am.
So we are moving to, yes, please, time is constant. So please let's solve the next question. For a food reaction with an activation energy of 600 kilojoule per mole and an initial rate constant of 7 m-1 s-1, which is in the second inverse, the mole and the second inverse, and at 113 degrees Celsius. Find out the temperature at which the rate constant will gonna increase to 15. So let's just solve this question. It is also the question based on the Arrhenius equation. So we know the Arrhenius equation is K equals to AE minus EA by RT. So we can simplify this equation, the Arrhenius equation, in the form of when there are two rate constant and the two reactions. So we can write K for condition 1, the K1 equals to A E to the power minus EA by RT 1. And for similarly, we can write this for the rate constant for the 2, which is K2 equals to AE to the power minus EA by RT2. So when we divide this, we can take the first the log ln, which is which will gonna convert ln K1 equals to ln A plus minus EA by RT1, which we have already seen here, right? This one. So this is for like we can write ln K for K1 condition 1 ln K1 equals to ln A plus ln E to the power minus EA by RT1. Same we can write for the 2, which is ln K2 equals to ln A plus ln E to the power minus EA by RT2. And when we divide both of them, we will gonna get this equation ln K2 by K1 equals to EA by RT 1 upon T1 minus 1 upon T2. I hope you are like very familiar about for like this equation. You must seen in your any of your subject during the when you are studying any of the subject, and when there is a reaction and it's temperature dependent, so you must have seen this equation, which we have just now
Yes,
discussed.
ma'am.
Yeah, how we get also this equation. So now the temperature T2, which is given in the question as 113 degrees Celsius. So here in equation we are converting degree Celsius into the Kelvin, which is 273 plus the degree Celsius, which is 113, equals to 386 Kelvin. K2 is given as 7, K1 is given as 15, the activation energy is given as 600 kilojoule per mole, the gas constant we know 8.314. So using this equation, we can put ln K2 is 7 divided by the K1, which is 15, equals to EA, which the value is 600 kilojoule per mole. So it's kilojoule. So we are multiplying by 1000 divided by R, which is,
Hello, ma'am. Some doubts.
yes,
Hello, ma'am. According to question, K1 is 7 m inverse and second inverse, but K2 is 15 m inverse and second. According to question, I have some doubts. How it is possible K2 is that the initial rate constant is same 7 m inverse and second inverse.
yes,
Please clear it.
yes, we can take you are saying that 7 should be K1 and K2 is 15, right? This is your doubt.
Yes, ma'am, because initial rate constant is 7 mole inverse and second inverse.
Mm.
I'm not sure,
So
but I have some doubts.
yeah, I can understand. So like if if at all we change the order of K1 and K2, there will not be any effect in the solution, uh, uh, because they both like if here is K2 at the like in ln, if the at the numerator is K2, then the T2 is in the second side, which is on the minus. So I don't think there will be any change in the solution part, so we can assume any of as K1 and K2.
Okay,
Yes.
thank you.
Also, yeah. So I am taking K2 as 7. So I am like on this correspondingly, I will take T2 as 113. So they will not be gonna change. So ln K2, which is 7 by 15, which is K1, equals to EA, which is 600 into 1000 because we are converting into joule, kilojoule to joule, divide by R, which is 8.314, multiply by 1 upon T1. T1 we are taking as unknown here because I am correspondingly writing here 15 as K1 minus 1 upon T2. T2 is 386 Kelvin or 113 degrees Celsius. But this equation, in this equation, we will always put Kelvin, not the degree Celsius. We have to convert. So ln 7 by 15. So it's in the divide form. So we can write ln 7 minus 15. When it will expand, it will be ln A minus B. So ln 7 minus 15 equals to this value. We multiplied, divide by 8.314, and rest is 1 minus T1 minus, sorry, 1 upon T1 minus 1 by 386. So solving ln 7 minus ln 15 will give the value of ln 7 is 1.9459 minus ln 15 is 2.7081. So this one, and now we are this value will going on the left hand side. So 8.314 divided by the activation energy, and since it's in here plus on the right hand side, if we send here, it will be in change of the sign, plus 1 upon 386. When we minus this value, we will get this minus 0, like 1.9459 minus 2.7081 will going to give minus 0.7622 into the gas constant divided by the activation energy is 1.386 into 10 to the power minus 5, and our this temperature 1 upon temperature will which is 386 is converted, and it's we solve it as 0.00259. So 1 upon T1 is equals to, when we multiply this minus 0.7622 into 1.386 into 10 to the power minus 5, this will gonna give 1 minus 1.056 into 10 to the power minus 5. And when we solve, this is minus, this is plus, so we will subtract and we get this as our value. And since it is 1 upon T1, so T1 will gonna be equals to 1 by 0.00257944. So which is give the 387.681 Kelvin, which is in degree Celsius 114.681 degrees Celsius. So the closest answer is option A. Is there any doubt in the solution part?
Ma'am, during examination, calculator is allowed or not? How it is possible? It is the lengthy calculation of the question.
Yeah, I think scientific calculators are usually allowed everywhere.
Okay, thank you.
So next question is, which of the following microorganisms is effectively inhibited by reducing the water activity to 0.62, below 0.65 to 0.60? The water activity, when it becomes minus, like when it goes beyond 0.65 or 0.60, then which microorganism can be effectively inhibited? The Clostridium perfringens, Saccharomyces roxy, S. aureus, Vibrio hemolyticum.
B.
So from this question, which one?
B.
C.
B
Staphylococcus
and
aureus.
C. Two people corrected two
Ma'am,
options.
C. Option C.
Option C.
Option C.
Okay. Let's discuss
Option
first
C.
what is water activity. We start from water activity. So, water activity is basically the ratio between P by P naught, which is vapor pressure of the food itself when there is a completely undisturbed there is a balanced uh, condition with the surrounding atmosphere to the vapor pressure of the pure water in the same condition, identical condition. We know the second term which we talk about is mostly with the like the moisture content, water activity, and then equilibrium relative humidity, which is equals to water activity into 100. And water activity, it increases with increasing in the temperature, and most of the food we have is the water activity greater than 0.95. And because of so much of the water activity, the bacteria, yeast, and the molds they can grow, right? So we have different water activity ranges for different microorganisms to grow. So the molds, they can grow even at 0.7, like a lower water activity value, the molds can grow, and the higher the value, which is around greater than 0.9, the bacteria will grow. And yeast, mostly they grow at 0.88 to 0.91. And there are the water which are present as the concept of bound water and the free water. Mostly we measure, like we have the water activity which is about like the free water which is there in the any food product is known as the uh, water activity. And the moisture content, it includes both the bound water and the free water. It's a combination. So now let's discuss this solution part of, we discuss the concept of water activity, what is actually. So from that we can understand now that if the water activity is very low, then only the molds can grow mostly, but there are exceptions also which can grow in the lower water activity also. So option B, which is a Saccharomyces roxy, it is correct because it's an osmotolerant. Osmotolerant means it can, at the high osmotic pressure, which is like when we add so much of the salt and the sugar, it can grow in that, and in that uh, hard or the harsh environment also. So this yeast can grow at lower water activity conditions. So if we want to if we want to suppress its growth, we have to decrease the water activity below this limit. So the option A, option C, and option D, they are the microorganisms which grow like greater than 0.8. So they cannot be true. So option B, because it's an osmotolerant yeast, so it can grow in lower water activity, but if we decrease further the water activity, it cannot grow that time. Okay, is it correct? So let's move to the next question. Column 1 is about the different water, which is type 1 bound water, type 2, type 3, and type 4. And the column 2 is about its characteristics. So we need to match. So let's discuss. So we have the type 1 bound water. Type 1 bound water is the water which is very close to any food product. very close. So it is the option B, which is partial removal of this type of water can be accomplished by dehydration. When we do the dehydration from the conventional drying method, then we can do, but that to be partially it will be removed. It is that tightly bound that any like for that like any solvent dependent reaction if we do so then also it is not possible to remove. Type 2 bound water is the next one, which is it allows the hydrolytic enzymes activity and non-enzymatic the browning reactions. It allows these, but in this microorganisms cannot grow. Also, the chemical reactions they will be very slow. It will not support them also. So the second is C, which is it permits the enzymatic activity, which is the only the hydrolytic activities and non-enzymatic browning. Option 3, the type 3 bound water, it supports the enzyme activities, hydrolytic and oxidative and non-enzymatic browning. So type 3 bound water, it is physically trapped within the tissues and the matrices and the solutions, and it is accessible for the microbial proliferation. Both the hydrolytic and oxidative enzyme activities as well as the non-enzymatic browning. So this water is easily available to microorganism, whereas the type 1 and type 2 bound water, they cannot be available to the microorganisms to grow. Type 4 bound water, it is like in the free state. As we can see in the diagram, the free state water is the type 4 bound water, which is exist in the free state. So option D is correct. So till now I think it's clear. If anyone has doubt, please ask so far so that we can move to next question.
हेलो
Yes.
हेलो मैम, मैं ये बोल रही थी वो ये नोवल टेक्नोलॉजी वाला जो स्टार्ट किया था, मतलब वो क्लासेस वगैरह, तो वो सर ने बताया था ना कि ऑनलाइन एग्जामिनेशन होगा कोर्स के एंड में.
I'm not sure. I told you about this. Not sure. I will get back to you on the discussion forum all your course related doubts. If you have any doubt regarding the problems or the practice problems, please ask. Like if you have the doubt regarding the lecture videos also, I can solve. But all the other doubts, I will ask and I will confirm and I will try to answer you.
Okay, ma'am.
Ma'am, there are four different kind of water activity that you mentioned here. So
Yes.
the type 3, which is available for microbial proliferation. So
Yes.
how is it possible? Like we can create gel form to reduce this activity, or there are any other option?
This is the like what you want to know that
I
we
want to reduce the water activity to
yes.
from 0.8 to 0.6.
Okay.
So how is
So
it possible? Like
this will be
what are
removed. This water will
this
be
will be
removed.
removed?
The type 3 bound water, it will remove. The type 4, it is a free one, free state. So it will remove. Even we can remove type 1 bound water, but through the drying processes, but the partially only we can be able to remove it.
Okay. Okay. So if creating it to gel formation, that support us?
Gel formation also have so much of water, but in the intact form, so microorganism can grow there as well. But
Can grow there as well.
yeah, then the gels and then the like in the jams, if we talk about when there is a gel structure, but there is so much of the sugar, and usually the jams in the market, they have the antimicrobial agents in it, so it doesn't affect that. But if we leave the starch, um, you then we leave the starch or any product which takes the water and swell, which has so much of water, so it will, in that microorganism will easily grow. But in the gels, because of the high content of the sugar, because it bounds the water, the microorganism do not grow. So
it helps bound the water, right?
bound the water, yes, it bounds the water. But
It helps bind the
usually,
water, but
yeah,
the strength need to understand.
yeah, it's like all are in the, we are talking about all in the, like we have in the food, so there will be the molecules. The molecules will try to, like they have the force, the intermolecular force, so that force will bound all the water.
Okay.
But
Okay.
to which extent? So the closest layer will be the type 1 bound water. After that, the type 2, type 3, and type 4. Type 4 is, it's not just like free like this, like we can, like in the, how we can say, it's not just free. It is also a
Like I
bound kind of
consider
form.
emulsion, oil to water emulsion.
Yes, but it's in free form. Even if we say about the like vegetables, right? It is
Yes.
looks like a solid, but it is having also having the water in it
Yeah,
and
right.
the free
Yeah,
water
got you.
in it. But and
I got
also
you.
it, yeah, microorganisms can also take that water and have the nutrition and the water and can grow there.
Okay, I got it. Got it.
Hmm.
Thank you. Thank you.
So let's move to the next question, which is determine the kg weight of the parboiled paddy initially containing 40% moisture on the wet basis needed to produce 1 ton of dried paddy with a final moisture content of 12% weight basis. So let's try to solve. The option A is correct. How it is correct? Let's see. So we need to calculate kg weight of parboiled paddy, and it's having the moisture content of 40% moisture on the wet basis. So we can see in the question that initially containing 40% moisture, and we need to calculate its weight, right? So the initial moisture is 40%, and we need to calculate the initial weight. And also it is given in the question that weight of the paddy is 12 like it's 1 ton, which is having 12% of the moisture on wet basis. It is also given, right? 1 ton of the dried paddy, final moisture content 12%. So from this we can understand that if there is 1 ton of the paddy which is having 12% moisture, so what is the weight of the bone dry paddy, which is 1 minus the moisture content in the paddy, right? Which is 12 divided by 100 into 1 ton, which is the weight. So it will be 0.12. So 1 minus 0.12 equals to 0.88 ton. So this is the weight of the dried paddy. Now we know that the moisture content on the wet basis is mass of the water divided by mass of the water plus mass of the dry sample into 100. So now we can calculate how much water is present in the paddy when there is 40% moisture. So mass of the water we need to calculate. So x, we are taking x by mass of the water, which is x, plus mass of the dry sample, which is bone dry paddy, which we have calculated as 0.88 ton. So x divided by x plus 0.88 into 100 equals to moisture content. which is which is given as initial moisture content as 40% equals to 40, right? So from this equation, we can calculate the value of x, which is x equals to 40 into 0.88 divided by 60 equals to 0.587. So this is this is the mass of the water. So in the in the initial paddy, when there is 40% of the moisture, the weight what is the quantity? So quantity will be weight of the water plus weight of the dried paddy. So weight of the dried paddy will be fixed, it will not gonna change. So it is 0.88, which is the mass of the dried paddy plus the mass of the water, which is 0.587 when there is 40% of the moisture. So it is 1.467 ton, which is 1467 kgs. Is it okay?
Yes,
Yes,
yes.
ma'am.
Okay, okay. Clear.
Okay. So let's move to the next question. Calculate the water activity of honey given that it is an 80% weight by weight aqueous sugar solution with 90% hexose and 10% disaccharides. So we need to calculate the water activity in the honey. In this, it is given that 80% weight by weight is the aqueous sugar solution. Out of the 80%, 90% are hexose and 10% is a disaccharide. So if we are assuming honey weight is 100 grams. So if honey is total 100 grams and 80% is the aqueous sugar solution, that means that 20%, which is 100 minus 80 equals to 20, is the weight of the water, the water weight by weight value. So water is 20%, which is of the 100 grams, it is 20 grams in the honey. 20 gram is the water, and we know that the molar mass of the water is equals to 18 gram per mole because its formula is H2O. From the formula, we can calculate 2 into 1 is hydrogen plus 1 into 16 is the oxygen, which is 18 gram per mole. So now we can calculate the moles of the water, which is the mass divided by the molar mass. So mass is given as 20. We have calculated as 20 because it's the from the 20% of the honey, which is 20 gram. So 20 divided by 18, its molar mass equals to moles 1.11. Now about the hexose, it is saying that 90% of the sugars are the hexose, which means that 90% of the 80 grams or the 80% of the sugar is 80% weight by weight. So which is the if we do 80% of 100 gram of the honey, which it is 80 grams. So it is of the 80 grams, the hexose are 90%. So which means that it is 0.9 into 80 is 72 grams of the hexose are present, and molar mass of the hexose based on the formula, if we calculate, is 180 gram per mole. So we can similarly calculate moles of the hexose, which is mass by molar mass, which is equals to the mass as 72 and molar mass is 180. So sorry, this is the moles. So 0.4 moles. It's not gram mole, it's moles. Similarly, we can calculate for the disaccharides. So 10% of the sugars are disaccharides, which means that a 10% we need to calculate of the sugar, which is 80 grams. So it means 0.1 into 80, which is 8 grams. So and the molar mass of the disaccharides, the formula is this, the molecular formula is this. So we can calculate 342 gram per mole as the molar mass. So we can calculate the moles of the disaccharides equals to its mass, which is 8 divided by molar mass, which is 342, and we can calculate its moles 0.02 moles. So if we need to calculate the water activity, right? So water activity formula is equals to the is the same as the mole fraction, which is when we assume the Raoult's law, the water activity of the honey equals to mole fraction of the water. So it is equals to moles of the water divided by moles of the water plus the moles of the sugar, which is the moles of the water we calculate as 1.11 divided by the moles of the water is 1.11 plus moles of the sugar, which are the hexose and the disaccharides. They are the 0.4 mole, and sugars 0.02 moles. So 1 divided by 1.11, 1 divided by 1.11 divided by 1.11 plus 0.42 equals to 0.725 is the water activity of the honey when it is having sugars as 80%, 20% as water, and out of the sugar 80%, 90% are hexose and 10% are disaccharides. Is it okay? Hello.
यस
Yes,
मैम
ma'am.
ओके
Yes, ma'am.
मैम
Yes,
ये
ma'am.
पैडी वाला जो स्लाइड था वो मिस हो गया, प्लीज एक बार दोबारा उसको वो कर देंगे क्या?
सॉल्यूशन एक्सप्लेन कर दूं?
केवल वो उसका आंसर मैम, सॉल्यूशन तो मैंने देख लिया था, वो रह गया था.
Okay, okay.
Ma'am, will you share this PDF with us or not?
Yes. I will be sharing the
Okay.
PDF, so no need to click the pictures of the slide.
Okay. Thank you, ma'am. Thank you.
Okay, thank you, ma'am.
Okay. So next question is, when the
Thank you.
water activity of a solution is not equals to the mole fraction of the water, when for AW is not equals to XW, then by which by which factor they can be related? The ratio of water activity divided by mole fraction is known as.
All of the above.
Ma'am, unmute.
Ma'am, you are muted, ma'am. Ma'am, you are still muted.
Hello.
Now audible, ma'am.
From which time it was mute?
Last few seconds.
Okay. I'm sorry if some
1720.
interruption.
520. 520.
If something like this happens, please let me know.
Sure, ma'am.
So, yeah, we were here. So, what the factor is known as? If AW by XW is not equal, so the ratio is known as activity coefficient. So, in the case of the ideal solutions, the AW will be equals to the mole fraction. The water activity will be equals to the mole fraction. But in the non-ideal solutions, the water activity will not be they'll not be equal, and the activity coefficient we know like with AW by XW, which is a water activity divided by the mole fraction, is equals to activity coefficient, and it is the factor of the correction for the non-ideal solutions. Next is the using the
Ma'am,
given.
can you please explain the last question once again?
Yeah, when there is an ideal solution case, what happens in ideal solutions? We have two type of solutions: ideal solution and the non-ideal solutions, right? So in the ideal solutions, the water activity it will be equals to the mole fraction, the whatever the mole fraction is there, which is the amount like the water. In the last here we discussed, like when we assume the Raoult's law, the mole fraction of the water, it is equals to the water activity, which is equals to the moles of the water divided by moles of the water plus moles of the sugar or any other component like the protein, carbohydrate, anything, right? The food constituents. But if in the case when there is it's not following the Raoult's law, it's a
Ma'am,
Ma'am,
you are muted, ma'am.
Ma'am, you are muted.
okay. I'm so sorry. I don't know why it is getting mute. Okay. Am I audible? Is it mute or unmute?
No, ma'am, you are audible.
yeah,
Okay, okay. So what happens is, in the case of the ideal solution, which follows the Raoult's law. So the water activity is equals to the mole fraction. So the mole fraction, from this formula we can calculate the mole fraction, which is the moles of the water divided by the total number of the moles, which is the moles of the water, protein, carbohydrates, any component in the food. So it will gonna equal to the mole fraction, and it will give the result of the water activity also. But if our solution is not following the Raoult's law, then that means it becomes the non-ideal solution. So in this case, the activity coefficient comes into the picture. So water activity is not equals to the mole fraction, here is equals to the activity coefficient into the mole fraction. So the correction factor here is activity coefficient.
Ma'am, you are muted, ma'am.
Muted, ma'am.
It is getting mute now.
not Victor, you are audible.
It should be okay.
Now you're audible, ma'am.
Okay. Should I explain this again, or is it clear, this question?
No, ma'am, I got it. I got the point.
Okay.
I got it,
Okay.
ma'am.
Thank you, ma'am.
Okay. Next is the using the given BET line data, where the intercept is given as 13.7 and the slope is given as 0.98. We need to determine the BET constant and the monolayer moisture content, and M1 we need to calculate. So first of all, what is BET? So BET, basically there is an equipment known as BET which works on the principle of BET theory. So in that equipment, what happens is it works on the principle of physisorption, which means that in any adsorbent is our any of material. Maybe it can be food or it can be any solid or porous material. On that, the water molecules or like the water vapor molecules or the gases molecules like the nitrogen, any molecules like in the form of the gas, they form the bond, the physical like it's a physical bond, physical adsorption. So it sticks on the surface, but they will not be having any chemical bond formation. And since we know the molecules which are coming, which we known as the adsorbate, uh, and the surface like the food or any material, it is known as the adsorbent. So the adsorbate molecules will form the physical bond or the van der Waals forces. With the help of van der Waals forces, it forms a bond with the adsorbent. It's known as physisorption. So on this principle, BET works. And uh, in the BET, what happens is, since on any solid material, uh, if the water is coming, attaching, or any gases, molecules, they are coming and attaching, so uh, we can have this equation which is known as BET equation. So in the in the BET equation, what happens is, the equation, it basically relates it relates how, when we are changing the partial pressure, uh, or the partial pressure divided by the uh, true pressure or the saturation pressure, which is known as the water activity, which is P by P naught, water activity. It relates it relates that to the how much of the water is absorbed, or the gas or the volume is getting absorbed, how much volume of the of that nitrogen or the water vapor it is getting absorbed on any material. So the equation, yeah, so the equation, it has the equation P by M multiply P naught by P. So here P is the partial pressure of the nitrogen or the water vapor in the food, divided by the M, which is the moisture content at that pressure. So it will be the volume of the moisture content, and like how much water is coming and getting absorbed on any food material, or how much water is present in any food associated with the food. Minus multiply P minus P naught, which is the saturation pressure, minus में partial pressure, okay, equals to C minus 1 upon M1 C. So C is here the BET constant, as per the BET theory. P minus 1 upon M1, which is the, when there is formation of the water layer on any food product, there will be the like many layers, like even monolayer can form or multi layers can be formed. So here we are only considering that if water is coming and attaching to the food surface, it's just the monolayer formation. So how much the volume of the water uh, is attached to the food surface is the M1. Multiply the water activity, which is P by P naught, plus 1 upon M1 C, which is the monolayer moisture content, since we are assuming only the monolayer is forming, not multilayer, into C, which is the constant, BET constant. Here, this equation, uh, since it's P by P naught is water activity, so we can rewrite this equation as water activity divided by the volume of the moisture at P, multiply 1 minus water activity equals to C minus 1 upon monolayer volume multiply C, which is a constant, whole multiply with the water activity, plus 1 upon M1 C, which is the monolayer moisture content in the that's volume, and the BET constant. Since this equation is, we can see it looks like a linear equation, y equals to mx plus c, right? And when we get the information from this equipment, or is this from the machine, we get we get one of the curve like this, which is here we can see on the left side. Sorry, on the right side bottom, we can see that this is the curve, right? On the x-axis, it's P by P naught, which is water activity, right? On the right hand side, it's this one. What happens?
Ma'am, in the left side, that is a volume of volume of water or volume of other product
It's the volume, anything you can
of
take,
any
right?
other product.
When, yeah, even if it's the product in the gaseous form, so it can be nitrogen, it can be water vapor, it can be any product, like it can be the volume of any gas, any
gaseous substance.
any gaseous substance which is coming and getting absorbed on any solid surface.
Okay, ma'am.
It is it is a general formula, and we are interpreting it in the form of the food, and actually it's there in the chemical engineering also, this formula, and it's the general formula, this BET theory, and we are interpreting it in the our food system, how when water is coming to food, what it happens, how it forms, like it bonds and it forms the monolayer or the multi-layer, on how it, the pressure varies, or how the water activity is related. We are doing this because this curve.
Ma'am, when will the saturation pressure point will come in this process, ma'am?
Saturation, when all the water is absorbed, like the pressure of the environment, the partial pressure of the environment is equals to the pressure on the water, the pressure of the water in the food. The pressure of the water in the environment equals to pressure of the water in the food when it the equilibrium condition.
Okay, ma'am.
Yeah. So when we plot, it gives more like a similar like a similar curve, like a linear line equation, right? So we assume that this equation will going to behave like a linear equation, y equals to mx plus c. So from this we can say that the c, which is the intercept, is this value 1 upon m1 into c, and since x is water activity aw, this is this term is the slope, which is c minus 1 upon m1 c. This is the slope, and this the hole in the left hand side, it's the y. So this is y, this term is the y, this is the slope, which is m, this is aw is the x plus c. So this is BET. Now let's come to the question. Using the BET, we are using this equipment, and we are getting the intercept as 13.7 and slope as 0.98, and we need to calculate the BET constant, which is C, and the monolayer moisture content. So intercept is given as 13.7 already. Slope is given as 0.98. Now we can solve these two equations. And when we put the value of the intercept, which is 1 upon m1c equals to 13.7 into the equation 2, which is the slope equation, c minus 1 upon m1 into c. So we can get equals to 13.7 into c minus 1. So and this slope is equals to 0.98. When we solve this, we get the c equals to 0.98 divide by 13.7 plus 1. We get C equals to 1.07. And from equation 1, which is the intercept equation, 1 upon C, m1 C equals to 13.7. m1 we can calculate as 1 upon 13.7 into C, which is 1.07. So it is equals to 0.0682 kg of the water per kg of the dry matter. So M1 is the, we discussed, monolayer water content. So here from this M1 we can calculate the how much is the water present. Is there any doubt?
No, ma'am.
Okay. So next question is on the Q10 value, which we all food technologists are very much aware. So Q10 value of any reaction is given, and the temperature, like Q10 value we need to calculate. Temperature, there are two temperatures, and the rate of the reactions is also given. So as we know that Q10 value is the temperature coefficient, which is a, like, it tells about the factor by which the rate of the reaction increases when there is a 10-degree rise in the temperature. Okay, when there is any reaction going on and 10-degree difference is there, we get, like, we have the formula to calculate the Q10 value, right? You have all studied about Q10 value. Have you? No. Please try to discuss. If you write in the chat, if I'm sharing the screen, it's not possible. Like, it's there. My presentations are going on, so I cannot see the chat during the discussion. So there are Z value, T value concept. Have you, like, ever gone through Z value, D value, and Q10? There, it's in that same Q10 also comes. Hello.
No. मैम जेड
Okay.
वैल्यू एफ वैल्यू ये सब तो पढ़े हैं
Yes.
Q10 याद नहीं रहा
It's the same, it's like in the same chapter, it's there, where there is this F value, Z value, and D value. So maybe I can tell the relation in the next class, this about the Q10, but it's in the same chapter. Like when we discuss about the preservation, mainly how we are preserving with respect to the temperature, from, like, in that that only it comes. So the Q10 is basically like how like when we are increasing or decreasing the temperature by 10 degrees Celsius, then what happens to the rate of reaction? Rate of the reaction means, like, when we have the enzymes which we are reacting with some rate. So how it changes when how it's affect when there is a change in the temperature, like if we increase the temperature like 100 folds, which is, or the 10 folds, or like that, how it affects. Yeah, so the Q10 value is equals to the K2 by K1 to the power 10 divided by T2 minus T1. K2 is the reaction rate at temperature 2. K1 is the reaction rate at temperature T1, where the T1 is less than T2. Like it's like we are at T1, we are treating we are conducting our um, uh, like we are putting our food in one temperature condition where enzymatic reaction is going at some uh, rate which is K1, and when we increase the temperature which is T2, so the reaction rate is changing to K2. So K2 by K1 is this, and if we put our value in the Q10 formula, which is equals to Q10 equals to K2, which is the rate of the reaction 22 divided by the initial rate, which is 16 to the power 10, because 10 for every 10 degree Celsius we are increasing. If we are changing the temperature as every 10 degree Celsius, what is the change? So this 10 factor comes in this formula from there. Divide by 21 minus 16, which is T2 minus T1. Here we takes the value in the degree Celsius, while in the Arrhenius equation we never take the value in the degree Celsius. We always take the value in Kelvin. So when we solve, we get 1.375 to the power 2, which is 1.891 as a Q10 value. So I hope it's clear. Let's move to the next question. So this is the graph with respect with like the y-axis is the viscosity and the x-axis is the temperature, and there are points 1, 2, 3, 4, and this is the like we 1, 2, 3, 4. It tells about the pasting characteristic of the starch in an abundant water mixture throughout the heating and the cooling phase. When we change the temperature, how the viscosity changes in a starch water mixture. So here are the different points, like the 1, 2, 3, 4. These points, what it is called as. Hello. So this graph is well discussed in the lecture slide. That first we get the gelation onset, and then hydration of the starch granule happens at the 2, and then there will be the maximum intensity of the gelation. After that, there is the enzymatic or the shear degradation of the starch granules, and then the minimum viscosity will be there, and because of that the viscosity will be lost, and at the end when there is a retrogradation, the final viscosity like or the final viscosity we get, or when there is a like hardening is there, the paste gets hardened, the viscosity, final viscosity we get. So option C is correct. First is the gelation. First is the gelation. This point is the gelation point. This one is the gelation point. Then peak viscosity. This is the peak viscosity we get. Then here is the breakdown viscosity. And last we get the setback viscosity. Also, there is the pasting curve of the starch, which is also discussed in the lecture video. It is the graph between the apparent viscosity and the x-axis is the temperature or the time, where what happens when there is the starch and it in the water, it gets swell and it gets to the peak viscosity. After that, it like there will be some hold, and then there will be because there is so much of the swelling, and there is because of the swelling there will be more of the shear, and there will be breakdown of the viscosity, and after that we get the breakdown viscosity, where there is setback or there is the lowest, like after reaching to the peak viscosity, it goes further to the lowest viscosity. And then finally the starch, when it gets like it cools, when we are decreasing the temperature, it converted into to the higher viscosity. Also, from this pasting curve, we know that we can calculate, there are 5 parameters we calculate, which are the peak viscosity, the ease of cooking, the paste stability, setback or the cold paste viscosity, and finally is the stability of the cooked paste. This all were already discussed in the lecture, like the video lecture, which is shared by Professor H.N. Mishra. So I'm not going, I'm not discussing it in detail. If you have any doubt, you can ask me regarding it. So next question is, which of the following pasting parameters is indicative of retrogradation tendency of the starch? The paste stability, setback or the cold paste viscosity, stability of the cooked paste, or the peak viscosity. So just now we discussed about the pasting curve and the gelation, effect of gelation. So anyone of you would like to answer this question? Pasting parameters indicative of the retrogradation tendency in the starch. Which parameter?
Ma'am, peak viscosity.
Peak viscosity. Peak
Ma'am,
viscosity is
Setback viscosity, ma'am.
okay, setback. Peak viscosity is this
Setback
one,
viscosity.
and retrogradation happens somewhere here, right? Decrystallization of starch and retrogradation. So setback or the cold viscosity is the answer, because it's the, like, if we see in the graph here at this point, there is starch retrogradation, where the starch get recrystallized, right? Here, which viscosity is there? Setback viscosity, right? So this option B is correct. When the starch when the starch get heat, it gets gelatinized. But after it gelatinized, when we cool it, sometimes like the mostly the amylose, it goes into the starch retrogradation, right? Where rearrangement happens in the structure, and also the starch viscosity also gets increased. Next question is, we have 1, 2, 3 phases of the starch water mixture when we like heat, cool, and we put for the storage. So we have which stage defining what? Which is defining gelation associated with swelling, formation of ordered or the crystalline amylopectin molecule, or the formation of the ordered or crystalline amylose molecule. Anyone? This is our different phases occurs. So the first stage, like in the first, this one is when there is a gelation, and also because of the gelation, the swelling is there. Second is the amylose leaching and formation of ordered or crystalline amylose molecule. In this, amylose starts leaching, right? And here it recrystallizes or retrogradation, right? Or formation of ordered or crystalline amylopectin molecules. Have you gone through this in the lecture video? This is very important, that's why I'm asking.
Ma'am,
Yes.
ma'am, is everyday lectures are going on, ma'am?
Every day, no. I will be taking on every Sunday, same time, for each week, and you have all the lecture videos already. So, hello.
Ma'am, is live class
Yes.
mandatory?
Yeah, it's a weekly class. So if you have any doubt regarding any class, you can ask in any of the classes.
Ma'am, every Sunday this time is classes going on.
Yes, 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 yes.
Ma'am, in the weekdays, every day we can listen to the lectures, ma'am?
Yeah, because recording will be there, right?
In the site only, novel technologies.
Oh yeah, this recording what we are discussing today, that recording is there, and in the NPTEL we have all the like the week 1, week 2, week 3 videos, lectures, right?
Okay, ma'am.
So have you gone through this in the lecture video, because it's discussed in the video?
Yes, ma'am.
Yes, ma'am.
Right, this is important, like how the starch gets gelatinized, the starch granules, they get gelatinized, they get swell, and how it, like the amylose, it gets leaches out, and how like it, like the starch particles, it gets disrupted, and again then there will be the formation when we cool the amylose, it gets again crystallized and it forms the, like it again forms the ordered structure, both the amylose and amylopectin, right? Here in this diagram we can also see this is the restructuring again. Next is the process where an entire sample solidifies into a glass-like form without any crystallization of solvent or solute is referred to as, when there is a sample solidification into the form of like glass like form, it forms, like the bowl is the amorphous.
Amorphous state, ma'am.
The process, we want to know the process, in which process it happens.
Vitrification.
D, ma'am.
Yeah,
Vitrification.
yeah. It's vitrification, because in that, uh, like there is no crystallization of the solvent or the solute particles. Still, like it solidifies and it forms like glass, like the whole amorphous state, right? In the why not the amorphous state? Because it's an non-equilibrium, non-crystalline condition, and in this, what happens? Saturation prevails without the crystallization of the solute, and the supersaturated solution is considered as the amorphous. It forms like amorphous solid, which is having very high viscosity. But it's, I think some sound is coming, some kid sound. Can you please mute?
Ma'am, it will be depend upon solute and solvent particle size.
No, the particle size. It actually, the process of crystallization depends on the particle size. Uh, but the how the rate or the kinetics of the crystallization, how a solution is getting crystallized, then the particle size matters there. How the grain size and the particle size matters. What is the glassy state? Is it clear?
Yes, ma'am.
So what is the glassy state? In the glassy state, there is the amorphous or the non-crystallized form, uh, but there is like mostly the polymers, they form it, and uh, like the very small molecules like the water main and maintain significant translation and rotational mobility at temperatures considerably below the sample's glass transition TG temperature. Every material has a glass transition temperature. So the glass temp below the glass transition temperature, it will be there, and the translation and the rotational mobility, it will be like very high.
Hello, ma'am.
Yes.
Ma'am, last one answer I didn't get, ma'am.
This one.
No, no.
This one.
Yes, ma'am.
So what happens when there is a starch in the excess of the water and we heat it? So what happens is there is a gelatinization of the starch granules and it becomes swell. In this, from this size to this size, it will go. It will swell when there is a gelatinization, right? Then in the second stage, what happens? It's the cooling stage. So here, like after the gelatinization, the starch is swollen form, so big size, right? So what will happen? There will be a shear between the molecules, and there will be the because of that also there will be the cracking is there, and because of the cracking there will be the leakage of the amylose, and the particles of the amylose, they get disrupted like this.
Okay.
And we can see here in the structure, this is the more clear structure, that it like like it was before in the crystalline, but it is like non-crystalline. In this it becomes non-crystalline, and there will be like this kind of the cracks will form. And when we store the starch water mixture for longer time, what happens? There is this the amylose this amylose, it get disrupted, right? And it becomes like it becomes disordered. When we store for long time, it recrystallizes, it form like it comes into the order, and we can get this kind of the crystalline structure from this structure. It's the microscopic structure. So we see it becomes again the crystallized form of both the amylose and the amylopectin. Okay, is it clear?
Yeah, ma'am.
Yes, ma'am.
Okay, so we were discussing this, right? Winterization, we discussed about it. uh, so uh, we know that any of the material is having different kind of states, like the rubbery state, the glassy state, the amorphous state, the crystalline state, right? uh, but the glassy, rubbery, and amorphous, these states are not the, like one is the crystalline state, it's the like it's not, they don't come in the crystalline structure, crystalline phase. Rubbery is when it is the glassy state, rubbery state. The rubbery state is mostly related to the polymers. Glassy is also like related to polymers uh, mostly. Amorphous is the like the, it's randomly ordered, it's not the in the fully crystalline is, or in the polymeric chains, they are in the well ordered state, but in the amorphous it is not in the well ordered structure. So next question is, crystallization occurs in gels with a starch content of, and recrystallization tends to increase with the water content up to this. So crystallization, it in the gel, it occurs when there is a water content of, and then recrystallization also occur when water content is increased to which percent. So when there is a crystallization in the gels, then 50 to 60% that contains 60 to 50 to 60% of the starch. If there is 50 to 60% of the starch, then there is the crystallization occurs in the started happening in the gels. And when the, like, if we talk about the recrystallization, it intensify when the water content it reaches to 40 to 45% in any of the product. Okay. Keeping a starch gel with a water content of dash percent at a low temperature while its glass transition temperature is around blank degree Celsius enhances retrogradation. So storage of the starch gel with water content approx 45 to 50% when the water is there, then and at the low temperature, then the starch gel is there, right? But when the glass transition temperature, it becomes like minus 5 degrees Celsius, then retrogradation enhances. So anyone is having any doubt so far in any of the slide?
No, ma'am.
Okay, so topics we have covered today are mostly related basic about the food, the water activity, the quality attributes of the food safety hazards, and then there are the different processing of and the storage variables like the temperature, water activity, etc. We discussed about those. We discussed about the free water, bound water, and we discussed about at the end gelation and the pasting property. And for the next week, we will be taking Browning reaction, food proteins, principle of food preservations, and traditional food preservation technologies. So after this class, I'll be uploading the recorded video for week 1 on my YouTube channel, and the link is provided here. And this PPT will be uploaded on the Google Drive link, which is this. If you have any doubt or do I need to improve anything, please write to me at my email ID.
Can you share this on email?
If you have any doubt while you are going through any lecture, you can share your doubts to my email ID only, or at the discussion form.
I'm asking, can you share this Google Drive link and YouTube channel link on email?
Yeah, this PPT or the PDF, it's having this last page, which is this. So you can go to this drive, because I cannot share on each like email ID, right?
Okay, ma'am.
Yeah, so
Ma'am, can
I
you
will
share in
try.
chat?
Yeah, that is what I was trying to say. I will try to upload in the Teams. If you can access from there, you can access, like, if it's possible. Okay.
Thank you, ma'am.
So
Thank you.
this next
Got it.
session is on the next Sunday, 4 to 6. And if I need to improve anything, please let me know, because this is the first week lecture, and I can improve on those aspects. If you want anything to be included or anything to be excluded, please let me know.
And can you refer for this material?
Pardon?
Can you refer
Book?
some book?
Some books are already referred by Professor Mishra, and I think those books are enough.
Okay, ma'am.
Yeah, because those are covering every aspect of. There are many books. It's been suggested, so they are covering all the aspects almost.
Okay, ma'am. Thank you.
Thank you so much for connecting this session, and I hope to see you in the next session. Thank you so much. You can leave the meeting for
Good evening,
today.
ma'am.
Thank you, ma'am.
Thank
Good
you.
evening, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Thank you.
Thank
Thank
you.
you, ma'am.
Thank you, ma'am.
Thank you,
Thank you
ma'am.
so
Attendance.
much.
Ma'am, attendance.
Thank you, ma'am.
Yeah, attendance I'll
Thank you,
take
ma'am.
from the online. I'll take, no problem.
Okay, ma'am. Thank you.
Okay, thank you.